Thank you very much, Heng, for a very kind introduction. I'm delighted to have you on board as one of the editors, reviews editor for automation construction. So the latest impact factors were just announced yesterday. And so we're happy to have the world recognition for the hard work that we've been doing for almost actually exactly 3 decades to tell the truth. My presentation today is in an essential part due to the efforts of Mr. Mateusz Żarski, who is a doctoral candidate at the Institute for Theoretical and Applied Informatics at the Polish Academy of Sciences, with whom I have very close collaboration. And I hope that this presentation will result in future interaction and maybe some joint projects with the Hong Kong Polytechnic University, a world famous institution that Professor Heng Li himself is part of. So this conference is really an opportune time for all of us to get our efforts together to talk about the future developments of wearable systems in the area of construction industry. Of course, construction is the major contributor to the national economy, not only Hong Kong, but every developed country around the world. With that, the technological development of construction really reflects on the entire economy of every major country around the world. So let me share my screen to make sure that I get the presentation displayed for you. Okay, so let me go right into it. So in this presentation, I will cover the main hazards present on a construction site and their causes. Based on this, we will describe the latest trends in smart and wearable systems that can significantly improve worker safety, and describe possible developments in the near and more distant future. We will also outline the most important frontiers that we can reach with the help of the presented technology, as well as the currently conducted work that's under development. The high degree of health and life hazards prevalent on construction sites is, of course, recognized by all countries around the world. And as a result, numerous regulations have been created to improve worker safety. So in the USA, for example, we have Occupational Safety and Health Administration, which developed standard number 1926, 1926, and regulated, among others, all personal protective equipment, materials handling, or fall hazards. In China, on the other hand, similar regulations exist, covering both construction site safety and manufacturing plants as well. So these documents attempt to comprehensively address the issue of construction site safety by carefully regulating how to remedy every possible hazardous incident. However, despite the regulations and efforts put in place to manage construction sites, it is still not uncommon to face accidents on construction sites. So let me just quickly go back. This was the first screen, and we talked about those safety regulations in both countries, in USA and in China. Now we are on the topic of work-related injuries. As mentioned before, construction sites are the scene of many accidents, of course. In fact, construction is the most dangerous industry, where over 1/5 of all work-related accidents happen. So furthermore, albeit nearly half of the accidents are seemingly harmless, slips, trips, or falls, that result in minor injury or no injury at all. Construction site accidents account for 19% of hospitalizations and alarmingly high number of 25% of fatal accidents. So this is really disturbing. These statistics are just the tip of the iceberg, as they don't consider other deferred risks such as chronic fatigue, joint strain, and occupational burnout. At the same time, these are problems that we must overcome if we want to reach beyond our current limitations. So for many of the site hazards, possible causes have been identified. These lie with both the workers and the engineers responsible for overseeing and planning their work. The main causes of accidents on the part of workers are mainly errors in risk management and risk assessment and the performance of work. In the latter case, it may also be related to fatigue of a single muscle group, leading to a change in the way that the activity is performed. Not wearing protective gear and inadequate preparation of work surfaces are also common. These problems in turn can be caused by excessive routine psychological problems or burnout. Site managers, on the other hand, may fail to perform proper workers training or safety monitoring on site. It, however, can be particularly difficult as construction sites can reach enormous sizes and manual forms of supervision are limited and at the same time labor intensive. For project managers, the possibility of an accident may be raised by errors made in the planning stage, as in site planning and in individual jobs. So you can see that there are numerous causes of fatalities in construction, and hospitalizations are extremely burdensome and expensive, and even those small accidents cause significant impairment, and they slow down the production on construction sites. For the risks that we described, there are currently various prevention methods that are being used. These include methods that are based on behavioral training or training with virtual reality devices. However, the implementation of these techniques has not resulted in a dramatic improvement in construction site safety. Implementation tests of behavioral training have found that there could be no significant safety improvements if the goal of training or hazard perception remains unclear for the worker. On the other hand, virtual reality training, although providing vast scenarios covering different hazardous scenarios, remains impractical and tiring if large groups of workers are being trained. So similarly, virtual reality in real-time monitoring on a mapped 3D construction site proves to be not only tiring to the observer, but also impractical in the terms of tedious virtual model building in constantly changing environment. So the same problem affects real-time monitoring using sensors placed on site. So in this case, in addition to the ever-changing environments, the problem also concerns the increasing number of sensors that are needed with correspondence to the growth of the erected structure. So the larger the structure, the more elaborate sensing systems we would need. While these methods focus on hazards from a construction site perspective, regardless of the general systems used, worker safety is always most dependent on the worker himself. For this reason, we may need to focus on a more personalized approach. So on the opposite, on unpersonalized safety, is a personal approach that can be enhanced with the use of smart wearables. So what exactly are smart wearable systems? When we picture a small wearable device, we usually see a smartwatch or some sort of a fitness tracker. By definition, smart wearable is a worn electronic device with measuring, analytical, and transmitting capabilities. However, there is much more to it. Smart devices may take the form of glasses, various trinkets, and even tattoos. So, of course, some of the devices that we talk about would not have any practical use on construction site. On the other hand, however, they may entirely change the way hazards are being approached. One of the most promising technologies to date are smart textiles. Through embedded circuits or fibers, they may provide sensory data for artificial intelligence applications. So, for example, for recognition of work activities. So these are some of the devices that are being worn. And many of you know that Hong Kong Polytechnic University is a pioneer in textile research, and quite recently, Professor Albert Chan and his research team has engaged in award-winning designs and testing of heat-repelling textiles to be worn by construction workers. So the question is, how can we effectively use them for construction site safety? As it turns out, solutions already exist to improve in using them, and in addition, some devices can perform many tasks at once. We will describe now the various ways of using novel smart wearables in order to mitigate the most important construction site hazards. So the most common and dangerous accidents on construction sites, number one cause of construction fatalities are falls from heights. They also account for the largest percentage of fatal accidents anywhere in the world. When it comes to statistics of construction accidents, that's always number one cause of fatalities. So historically, the device that has saved the most construction workers is the safety harness, but its use is not always practical, and a lot of workers actually try to avoid wearing a safety harness. The occurrence of such a hazard can be caused by errors also in site planning, worker error, poor site preparation, errors in site security, or even by worker fatigue. Furthermore, falls are impossible to prevent completely. For this reason, methods of dealing with this danger can be divided into preventive and immediate. For preventive methods, we can account for methods that improve planning either through virtual reality or augmented reality goggles. However, obviously, this solution is not applicable on a construction site as it further limits the worker's vision. So that's certainly something that we cannot totally rely on. By far, the more sophisticated methods are those that detect the fall with internal sensors, like accelerometer, and this can relay the information to the appropriate devices. It can be done with various methods, ranging from smart shoes, like the ones you see on this video, to smart hard hats, or even commonly worn smartwatches, such as Apple Watch. Of course, there is more to this technology, and for example, smart shoes presented here also have the ability to charge batteries, and hard hat can also send an SOS signal and localize workers with GPS technology, but also there is more than one way to really approach this issue. So another one of the common construction site hazards is head injury. As with falls, it's impossible to completely eliminate this hazard, and the only effective preventive measure is to wear appropriate protective gear, and that's a hard hat, of course. However, studies show nearly 60% of workers use hard hats improperly, or even they don't use them at all. Especially in developing countries, you see that a lot, even in places like Thailand, which has a robust economy, but very poor safety records on construction sites. The way to mitigate this problem is to monitor the proper use of hard hats on construction sites. There's quite a bit of research on that front, including research done at the Institute of Theoretical and Applied Informatics. Apart from manual monitoring, that is labor intensive and ineffective, there are wearable systems that can do it autonomously. Some of them use RFID close proximity sensors placed on collar with corresponding tag on the hard hat. This way, whenever the worker removes the hard hat, the sensor detects that removal. Other devices use photosensors along with accelerometers to check if the hard hat is worn correctly and if it's actually strapped to the head of the worker. However, this technology can only be incorporated with other smart devices that allow for other features. That makes it even more practical. Smart hard hats equipped with augmented reality goggles can not only be used for checking correspondence of construction plans with construction site realities or performing measurements and materials management, but they can also detect various hazards. Also, with the help of internal measurement units, smart hard hats can detect occurrence of an accident and act accordingly by informing nearby workers. So the third most common construction site accidents is being hit by construction machinery. But let me show you this Trimble device that allows the workers to really see what has been planned and compare the work with the progress being made directly on the construction site. Trimble is in the forefront of smart head technology in various applications. And it's a company, of course, also with robust presence in Hong Kong and in other surrounding areas of Hong Kong. So you can see that the HoloLens technology allows for quite a few innovative applications directly on construction sites. So you can see how that's actually being done. So the third most common cause of construction accidents is that of being hit by construction machinery or being jammed between a machine and a constructed wall or any other component of the structure. At the same time, it is a difficult hazard to avoid because it's made up of many factors such as construction site planning, visibility from vehicle cabs, and pedestrian orientation on trafficked paths. So we'll return to the first solution later in this presentation and focus on the last two solutions. The enhanced vision systems can be used for vehicles operating on construction sites to provide a larger field of view, including vision of machines, blind spots, constructing a 360-degree view. In this way, machines can be operated using virtual reality goggles, and the operator himself doesn't have to be in the machine. A pilot solution that can protect workers directly are vests with built-in metal sensors that react to an approaching vehicle. When a vehicle is detected, they inform the worker of the danger so that they have enough time to react. Similar systems have also been used in safety helmets. All right, poisoning from harmful substances is by far the most common in the manufacturing industry, associated with the production of chemical reagents. And it is in this industry that wearable devices are most commonly used. However, even on construction sites, poisoning hazards may occur. For example, during installation and repair work, or when finishing surfaces with varnishes or resin floors. So in such circumstances, devices capable of detecting a single type of gas, such as carbon monoxide, carbon dioxide, or benzene, or multifunctional devices may be used. Some modern devices can also take the form of a smart watch, like the one you can see on this picture. They're also area-based, but obviously they cannot be classified as wearable devices. So turning to the other types of causes of accidents, we can talk also about overloading. What is that actually? Overloads and lifting errors may or may not be due to mistakes made directly by the worker or lack of training. In many cases, they can be caused by prolonged work and fatigue of a single muscle group. To prevent this, in addition to methods that use monitoring of the worker by, for example, pressure sensors, the worker's capabilities can be improved with the use of exoskeletons. So exoskeletons are wearable devices for single muscle groups, allowing you to hold your arms in the upward position for extended periods of time. They make it easier to assume a stooped position or transfer the load to stronger leg muscles. Enhanced exoskeletons can also support the entire body, increasing a worker's ability to lift weights. They can also be used after accidents to rehabilitate the injured workers. And in just a moment, you'll see actually the use of exoskeletons during rehabilitation. So this is more examples of showing the variety of uses of exoskeletons. They're quite remarkable. It started as a military application. Now it's widely used in civilian applications. You can see the worker being rehabilitated with the use of an exoskeleton. Various muscle groups can be rehabilitated as a result of using these devices. And so they hold a great promise. They're obviously wearable devices, so they are of interest to this conference. So problems such as fatigue, sleep, deprivation have similar effect on a person, not only reducing their effectiveness at work, but also they can be an indirect cause of other serious accidents. Moreover, these problems in themselves, in a sufficiently high intensity, may lead even to the hospitalization of workers. So to prevent both of these risks, continuous monitoring of the worker's condition is key. This can be done, for example, by smart wristbands or vests, similar to those used in physical activity monitoring. The monitoring could include the type and intensity of activity and monitoring sweating, the heart rate, heartbeat rate, blood oxygen saturation, or monitoring sleep quality. So all of that is entirely possible. Another possible technology are the previously mentioned smart shoes, which in addition to measuring physical activity, they can also tell us when you're lifting too much weight or working too hard. So quite interesting the possible applications that would monitor a variety of factors that affect the safety of the worker. So year after year, hazards associated with the environment in which the work is being conducted will also become an increasingly important issue. Already construction work can be carried out under adverse conditions. And with further development, mankind can strive to master those areas where living conditions are very difficult as well. So today, simple solutions based on electrically heated vests and overalls are available to provide additional warmth for the worker. Not the kind of vest that you need to worry about in Hong Kong, but definitely the countries with distinct four seasons, they can certainly use these vests and allow the workers to feel far more comfortably in a cold environment. Their heating time can last from a few to several hours, and the built-in system can also power other devices worn by the worker. At the opposite extreme to cool the worker, we already have liquid cooling systems that can last up to 3 days. And of course, these are still relatively simple technologies, but we can anticipate their rapid development if we look ahead and think about the structures we will erect at the poles, sometimes at deep underwater environments or even on other planets. So a variety of applications are possible on the horizon. So that's certainly something you need to take into account when talking about the development of this technology. So planning plays a very important role in avoiding and identifying accidents before they happen. Planning done correctly and efficiently is the key to avoid most of the risks that we've talked about before. There are, of course, planning methods rooted in modern management science, but these too can be improved with the help of smart devices. One way is to use virtual reality throughout the planning phase. This way, construction managers can look closely to the area they manage and feel the scale factor of their decision in human understandable form. A close look at planned space will help prepare it properly for transportation, communication, and even for site evacuation routes. One can also use augmented reality in order to collaborate with other planners in real-world environments. By moving away from displaying the object model on separate monitors, a team of engineers can look at the same model simultaneously, seeing each other and communicating with each other at the same time. This could become the modern equivalent of the physical models once built to debate its flaws and features. Other ways to use similar technology directly on the project site. This time, augmented reality can be used for visualizing and helping proper site management with the help of handheld devices. So handheld devices have been around for a while, but actually manipulating models and being able to point to certain features in the model and interact with other coworkers at the same time is truly a remarkable feature. So this time, augmented reality can be used for visualizing and helping proper site management with the help of handheld devices. And again, it can be used for performing measurements on site, checking conformity of the work with the model or discovering potential hazards. The same technology can find its use for site or construction inspectors. So for example, while performing annual infrastructure checkups. So some other problems can be solved with devices that aid in understanding and responding to the current situation, when the workers have to rely on their eyesight. With augmented reality, not only can basic work be assisted by adding information about the world being observed, such as unseen hazards, but also the management of emergency situations where the extent of damage or even human life may depend on the speed and correct response. One can imagine a situation where after an accident on a construction site, smart glasses with augmented reality technology will not only help to diagnose the injured person, but also show the evacuation route or notify the appropriate services. The technology allows you to look at and understand what you cannot see physically. At the same time, it should be remembered that this technology, such as VR, can impede vision, so its use must be made with caution. So that is quite important because we cannot go overboard with the use of technology at the same time creating other hazards. That would almost look like a racket. We're trying to solve the problem that we've created ourselves. So definitely not recommended. So as you can see in the previous slides, there is some overlap in functionality between many of the devices presented here, but none of them have the ability to protect against every type of threat. For this reason, smart devices need to be used synergistically to get the most out of them. Naturally, some of the devices, such as smart watches that monitor a worker's health, or shoes that allow them to measure their fatigue and the weights they carry, will be universal to most environments and workplaces. So both construction, maintenance, demolition, and so on. However, for specific smart device applications, factors that affect the nature of the work should be considered, such as climate, which plays a major role in environmental factors and comfort. Technologies can be used, technologies used can have an impact on harmful substances on the site. The number of workers can affect the effectiveness of the way that they're monitored. Machinery used on the hazards associated with deductions and type of construction on the risk of falls. So there's a number of these considerations that you have to take into account. Using the knowledge that's gained by observing the work of people using smart devices, we can try to go further with our ambitions to improve work and its safety. In fact, we're already approaching the point where we will be able to entrust hard physical work in part to robots. Everyone already knows the Spot robot from Boston Dynamics. It can, for example, move loads or monitor and spatially map a particular construction site. But there are already other human-like robots that can do human-like work on structures. In fact, robots can come in all shapes and sizes. They don't have to look anthropomorphic. Some can observe the safety of workers by driving around the construction site, while others can perform a specific task, such as plastering walls, as you see here. Other robots can create an entire steel and concrete structure using 3D printing technology, as you can see here. Now is the time where it's especially important for industries that have previously operated separately to work closely together. Together, civil engineering, robotics, materials technology, and AI can achieve previously unimaginable tasks. Now, in the following slides, I'd like to present contributions of the University of Maryland and the Institute for Theoretical and Applied Informatics to the development of technology, one application of which may be to improve the safety on the construction site. So in our work, we strive to combine cutting-edge technologies from fields such as computer vision, artificial intelligence, and the Internet of Things into cohesive systems that improve and enhance worker safety, and not just for civil engineering, but for other applications as well. So in the Institute, we focus on a universal approach to safety. For this reason, we try to use commonly available solutions that we can extend with the analysis of extracting data using artificial intelligence-based and algorithms. One of our ongoing works is the use of sensors that are commonly used in tracking physical activity in mental state monitoring. To do so, we use the data from heart rate, sweat, and accelerometer sensors and analyze it using recursive machine learning algorithms. We are currently focusing on downloading and developing a large training data set, but already the results that we are getting on the limited data sets are quite promising. So we also use a combination of machine learning algorithms and Internet of Things devices in our work. In one of our projects, we use the Bengal.js smartwatch mobile platform as an edge device for a system that monitors worker safety at the construction site. In addition to the smartwatch, we also use RFID tags and an air quality sensor in the same project. The entire system is responsible for monitoring the worker safety and performance, the presence of protective clothing in the form of a hard hat and harness, and air quality for sensing the presence of dust and the intensity of dust. The system was composed as a smart wearable system for general applications. In addition to the computation performed by the Bengal.js platform, we also use the Raspberry Pi Pico to retrieve data from sensors deployed on the workers' clothing. So as far as another task that we focused on was optimizing deep machine learning algorithms so they can also be used on edge devices for image analysis. This is a computationally intensive task and is most performed by high-powered graphics processors. In our method, we use the Jacquard index to select from general computational model only those parameters that match the task at hand. In this way, we were able to reduce the number of model parameters to less than 5%, while at the same time, by discarding redundant parameters, we improved the accuracy of the model. The graph shows the result of this work. The horizontal red line indicates the benchmark of our model to the baseline model running on a high-powered processor. As you can see from the left side on the graph, after applying our methods, we're able to significantly reduce the model inference time, even for low-powered devices such as Raspberry Pi. So to conclude, this is what our work currently looks like in the context of edge devices being used directly on project sites. Thanks to the algorithms that we developed, we can implement these models directly on drones. For example, to inspect the status of workmanship or the technical conditions of a building, or low performance computers monitoring construction sites to control safety. These methods, although not part of smart wearable systems, as indicated earlier, can also be used simultaneously with the mutually improving effectiveness. At the same time, Their use on construction site could give rise to another technological breakthrough, whereby the operation of various systems could be managed and coordinated by deep machine learning models. So thank you for your attention, and I hope you found the topics covered in this presentation interesting to you. Certainly the topics covered during this presentation are rapidly evolving. So their effective development towards improving safety on construction sites can only benefit from discussions being held in venues such as this conference. So thank you very much again.
Thank you so much, Merrick, for your very informative and interesting talk. Can I just take a chance to ask you, Merrick, actually a personal question? Now, for us, we always have to choose an important research topic to either study, to apply for funds and all this. Obviously, wearable sensors and AI now a hot topic. But if I have to design a research proposal out of this, what is your advice? The best pick from all of those?
You mean if you have multiple opportunities for different proposals?
No. You heard of GIF, right?
Yes.
It's like a NSF. I have to write the GIF every year.
Right.
Just your advice. What should be my topic?
Well, there is a lot of basic developments of technologies that are for generic use. Yeah, the funding agencies in Hong Kong are blessed with the variety of topics that they pursue. And I know because I serve as a reviewer for many of these proposals every year. And I can see that they combine the development of basic technologies with applications, and also monitor the effect of these applications on industrial sites. So I would say that if you combine the effort that leads to maybe perfection or customization of existing devices, maybe from other applications, and then integrate them into systems that are practical, that maybe even somewhat redundant, and show the pilot application of those systems, I think it would go a long way. Because what the industry is looking to, and also the funding agencies that are trying to respond to the needs of the national economies, whether being in Hong Kong or in the US or in Poland or any other country, they want to see the fruits of the labor of scientists and researchers like you, distinguished academics, to collaborate with industry as much as possible. And you've been obviously no stranger to collaboration with industry, because you've done it for years and decades, and with results that everybody knows about. You are the best funded professor at Hong Kong PolyU when it comes to these kinds of applications, and you have experience also watching what's happening in other countries. Obviously, you know exactly from close up view what's happening in mainland China, you know what's happening in surrounding countries, but you also know what's happening in the US and in Europe. And there is this emphasis on technology transfer, on the ability to come up with new applications of the basic technologies that have already been developed. So definitely, and then international collaborations, because you don't want to somehow diminish the value of these collaborations just because we're in the midst of, or tail end of the pandemic, hopefully. You want to restart these collaborations, you want to cherish them, and you want to build them into long-term interactive processes and collaborative processes that will build capacity for many years to come.
Thank you so much. Thank you so much for the advice. Is there any questions from the audience? I think we can still entertain 1 or 2 questions if we have them. Come on, you have to make impression, you know, from the chief editor of automation construction. If you want to submit papers, this is your best chance.
Well, definitely, I will very warmly welcome paper submissions from this distinguished audience, from the people attending this conference. In fact, we get pretty close to 3,000 papers, new papers per year right now for review. So we can only publish the very best. And many of the very best papers come from Hong Kong, from you, Heng, and from your colleagues, and many from mainland China, obviously, and other surrounding countries in the region. So we're blessed with having so many great contributors to our journal. So we owe the success of the journal to our authors who are doing great work around the world. So please submit to us your best work, and we'll be very happy to review and consider it.
Thank you so much. Last chance to ask audience. Do you have any questions for Professor Miroslaw SKIBNIEWSKI? Is possible to integrate? There's a question from online. I read it out. Is it possible to integrate various sensors? Oh, the question is gone. Oh, okay. To various sensors into smart gloves to monitor over. Can you read all the health of workers using IoT based on platforms? So that's to use smart gloves.
Well, definitely. It's only a matter of proper engineering and proper testing. And then if testing proves any shortcomings of the solution, then of course you have to move to the next stage of the development, work out the bugs, and make sure that the sensors transmit the right data to one another. And then that data transmission results in useful information that would allow the worker to feel and to manipulate, that would not deprive the worker of the dexterity of the human hand, because dexterity is really what makes the worker productive on the project site. So making sure that you have a proper amount of the degrees of freedom in a smart glove, then that the manipulation is not impaired by whatever mechanical constraints you put on particular joints inside the glove. So you have a number of examples of such gloves being used for remote work. Recently, I witnessed development of smart gloves as training devices for equipment operators that would replace the levers that are typically used on an excavator, for example, with the smart glove that the worker can operate very intuitively as his own hands. So, for example, making pitch and yaw motions, as well as scooping the earth, and at the same time feeling, so providing force feedback and position feedback. So it would revolutionize equipment training. It's in conceptual stages, but if someone wants to pick up on this idea and work with the major equipment manufacturers, say in mainland China, I think that could go a long way.
Thank you, Merrick. I will also remind by the chair that we have overused our time, but thank you so much for your wonderful, very interesting talk. Always, whenever I hear from you, I feel I learn something new. Thank you so much for your—
My pleasure. And I would like to end with the note that the Institute for Theoretical and Applied Informatics is very open to collaborations with colleagues and friends in Hong Kong and elsewhere in the world. So if there are future project applications, please keep us in mind. We'd be very happy to work together.
We definitely will link up with Mary and with you. Thank you so much. No.
Okay.
Thank you. Thank you so much.
Okay. All the best.
All the best. Thank you.